Hello world, welcome to my next tutorial solving problems with programming. This tutorial is the WSQ10 Babylonian method, and I just want to show a quick error that I had to face in doing this program. So we need to see this picture, then it's a lion, then we have to see the background. In this assignment you will write a function to calculate the square root of a number using the Babylonian method. You can search for that method, it will be easy to find. That it was one of the exercise of the quiz 11. So the function should, what to do is a function, the function should receive a number and return floating point number. Obviously you should test your function, so create a main program that asks the user a value, calculates the square root and displays that. So I have already write the program, I have it right here. So first we need to put, as always, the include IOString library to call out the functions of inputs and outputs of data in language C++. Then we have to include the library cmath library to call out the functions of math of data in language C++, mastery topic 1. Then we need to use using namespace std. In C++, we need a command that every time goes with the instructions of inputs and outputs of data that is called std, but with this command helps writing this std out of the main because the machine factorizes them. So we have first at the beginning of the program, we have the main, we give the function this value, a square root. This is the mastery topic 4, command of data in form of numeric value. With this command we give the value 16.23654 to a square root function. So then we give this value to the function that is a square root. This is a structure of a function where you have subroutines in order to make different tasks. In this case, we have a float function with the name square root, and we float parameter x and float parameter. I just want x parameter because I just want one value of x. So in order to have float results inside this function. So in this function, I have declared two variables, resp and a, initializing 0. Then we have a math operation between resp and x, and it stands for do the division between those values and save it in a float variable resp. Why? Because this is how I get started for x0 in order to begin the Babylonian algorithm. Then next we have a mastery topic 13, usual loop. So with while and do while, this command is the loop do while, and that allows you in doing at least once of the instruction in this loop. And while this case of the absolute value of a, of the difference of the variable a, and subtract resp don't be higher than 0.0001. It will execute forever every instruction of the loop level in this function. So inside in this do while, I have a command of data in form of text. In this text we show the authentic output of the value of resp in the terminal interface. Then we have a command that allows giving the value of the declared decimal variable resp to the declared decimal variable a. And then we have an operation between resp and x, and it stands for the Babylonian method between those values, and save it in float variable resp, that is this one. Then we have a command in the loop, the condition of the do while. This command is a loop do while condition that allows in doing at least one time of the instructions written in this loop. And while in this case the value of apps or the absolute value, that stands for absolute value, the difference of the variables a and resp don't be equal to the value of, or don't be higher to the leader, don't be higher to the value of 0.0001. It will execute for all the instructions leaving this loop. Then we have a command. This command, you have a return the value the previous operation of square root function inside of this statement in order to call it in the main function. So I give the main program this value, then this value calls this function, and you have this this algorithm method that you can search for the Babylonian method. If we go to Ken courses, we can know that that has a similarity of the algorithm of the Babylonian algorithm. So x0 can have a value, initial value of something. So I put it as resp over 2. As we can see, we are in the in this I'm going to go to this quiz. This exercise is also from the last quiz, and we see this file. So inside in this file, I'm going to show you just the Babylonian method. That will be this one. If you see, this is resp. This is resp. This is resp. This is resp, and this is x. That it will be the square root of this number. So when I counter those difference over 0.02, that it will be that, I will return the number. So thanks for watching. If you have any questions, leave a comment on my blog. Let me show you how to run this. I'm going to save it. I'm going to save this. I have saved it. So I will put WSQ10, and then I'm going to run it in order to show you. So at first we give you 16.123 numbers. So I will run it. ./a ./a.out. As you can see, you have the Babylonian method that stands for this one. So my calculations are true because it's for the square root of this one, of 16, gives you 10. I suggest that you can see all the number. That will be the approximation of this of doing this method. So thanks for watching, and I will see you next time.